ball dot set by 290, and if ball hits this 290 position, I've taken 290 because there is some weight in this ball. So it wouldn't look nice if I set it to 300. That would go out of the screen, like half the ball would go out of the screen and then come back. And whenever it hits this, the direction uh, will be reversed by this multiplying by -1. Similarly, for the bottom, this down border as well. And whenever the ball crosses this paddle, uh, player A's score will increase, and whenever the ball crosses this paddle, player B's score will increase. And then I will write that down for player A and player B, updating their scores. And for paddle and ball collisions, so
Okay,
this
Prasant,
is
can I see the
something.
update function? Like, do you have any update function in your script that gets updated on each frame?
Yes, there's the first line in that while loop. This is it. wn dot update.
Okay. Okay, why did you choose Python instead of Unity or Unreal Engine?
Uh, that is because I was teaching kids Python, teaching my peers Python.
Okay, all right. So you have made this project just for learning purpose.
Yes.
Okay. I think I have got all the answers of my question. So if any other judges want to ask, you can. From my side, I'm done.
Hi Prashant.
Area.
Just tell me one thing. Is there any novelty in the project that you are demonstrating?
Uh, no novelty as such. It is that I learned Python, so to demonstrate it on my resume that I know Python, I tried making this project. That's it. There is no novel cause in this.
That's great. Thank you.
Okay, so I'm satisfied with it. Hello, can you hear me? Hello.
Hello.
Mhm. Good, Prashant.
Hello, is there anyone else who want to show the project?
Any other projects, guys?
Team, are we having any another project?
Yes, we have a participant named Mr. Sachin. Mr. Sachin, please come forward. I request you to come forward and please present your project.
Hello.
Hi, Sachin. Go ahead.
Yeah. So I got this idea from a course I did on Coursera, but most of the things are done by me. It's about particle identification using machine learning, and there are in particle detector experiments, most of the work that is done is mainly on inferring observations from data we process, and to actually check for false positive rates and true positive rates on the ROC AUV curves, AUC curves. So uh, my idea is using machine learning and uh, going through the data sets to find false positives, or we can call ghost particles, and finding the real particles that are detected, like photons, protons, electrons, kaons, muons. So mainly my field is physics, so I am concentrating into the physics part of this.
Sure, go
Okay.
ahead.
Yeah, go ahead.
So there are like in a detector, in any particle detector there are four stages. uh, Excuse me, 1 minute. Yeah, so there are four stages, like tracking system, then EM calorimeter, then hadronic calorimeter, and then muon systems. So, and we have six particles: photons, electrons, muons, protons, neutrons, and ghost particles. So every stage has a different detector detecting different sets of particles. Like photons are detected in EM calorimeter, muons are detected in muon system. So we need to run our data collected through all the different tracking systems through our machine learning data set. And I have used xgrad boost classifier. I could have used some other, but I chose xgrad boost for its speed and the boosting capabilities. And moving ahead, I'll plot the like what is the procedure to identify them. There are two variables: transverse momentum and momentum. These are the identifiers for this project, and I'll plot them on the graph. And there's a mean identification value. So I'll be using that graph to actually predict if the training model is perfect or not. And the uh, excuse me. Uh,
Hello.
yeah, sorry, just a minute.
All right.
Okay, so the main qualification and quality identification is through the log loss of these samples. Log loss on cross-validation samples generated through the training dataset and the test dataset. And I am able to get about 82% accuracy till now. I am trying to perfect it, but for some reason I can't pass 82%. So that's what I need to rectify, and when it's rectified, I'll showcase my project.
Okay.
Thank you.
Okay, thank you, Sachin.
Thank you so much, Mr. Sachin, for presenting your project on this platform. It was truly enlightening to have a look at your work. Thank you so much.
Thank you. The pleasure is mine.
Any other participants we have?
Excuse me.
I would
I
request.
have a doubt. Does does our project need to have documentation along with it, or as I'm explaining the project, it doesn't have to need documentation?
Well, a demonstration of the project would be fine for now. Later, the team can tell you whether they need documentation or not.
Is there any other team that are left to be judged?
Is there anyone else who wants to present their project?
So, judges, we have another participant amongst ourselves. He is here to present his project. Mr. Mirpur Kashyap is with us and he is here to present his project. Please proceed, Mr. Mirpur.
Good evening, judges.
Hello.
Hello.
Good evening.
Yeah. Recently, I've started working on a rover simulator by Udacity, which has been free in their GitHub repository. It is a part of their robotics nano degree program, but I'm not part of the program. But I have just used it for free. So it's been only a week since I started working with it. I don't have any such code for it, but I'm trying to figure out a way to work with it. So I can just give you a brief demonstration of the idea and how I'm going to I will try to implement the idea of how I will prepare the algorithm. So as you can see, this is the search and sample return project. It is a rover simulator. It is part of the NASA sample return challenge. It has been modeled after it. So they they have given us a simulator which we will have to first train it by driving by ourselves in the training mode, and after that we'll have to train the data using the Python, and the recorded data will be trained uh, in the following codes. Hello.
Hello. Yep. Please
Yes,
go
I'm
ahead.
called.
Yeah, Yeah.
Yes, Nilothpal, we can
As
hear
you can
you.
see, yeah,
Go ahead.
Go ahead, Nilothpal, go ahead.
yeah, okay. As you can
Go
see,
Nilothpal.
yeah, okay. As you can see, they have given the Python codes, the templates for the Python codes, in which you have to edit the functions according to our idea of how we're going to implement the algorithms. The main code will be the driver.py code, which will be collecting all the data, and it will be the driving the simulator, simulation rover, and we will have to implement the main decision for how it will follow the path in the decision.py file. And similarly for perception, we'll have to use the perception.py folder, and the supporting functions for the supporting functions.py. So according to me, I have prepared uh, to I will show you a demonstration of the simulation. This is the simulator which they have given. It is given by the Udacity. There are two modes here. One will be the training mode, which we can train it by using the keyboard keys and the mouse.
Can other judges view the screens?
I guess you've been disconnected.
Yeah, yeah. Even I can't see him. I was I was wondering why I can't see it.
Hello.
Hello, Nitpul. We are not able to see your screen.
Wait. Is it visible?
No, not yet.
No, it's not yet.
Okay then. Hello. Is it visible now?
No, still can't see it.
Is it visible now?
Yeah, we can see you.
Yes. Yes, it's visible.
I'm actually now able to open the simulator. So I'll just show you demonstration video which has been posted by the university on their GitHub account. Simulator will be similar to this. I'm trying to implement the idea to follow the lane. It is actually the left one. So I will try to implement it so that it will follow the left wall, and then it will once it finds any rock, it is supposed to collect rock samples, golden rock samples. So once it finds any rocks in front of it, then it will collect and place it on of the rover. And for
Uh,
detecting the rock, I will
hello,
be using image processing.
hello, Ninut Paul. Can you please send
Yeah,
the GitHub link in chat?
yeah, understanding.
Okay, all right. That will be great.
Hi, Paul. Your connection is very weak, so we
Hi.
can't hear you properly.
Yes.
Better you prepare just share a document with us, like describing your project and your
Actually,
ideology. That would be better.
uh,
Yes, that would be helpful.
yeah, I can share the idea, but I really have don't have that much of information because I've just started working on it a few days ago.
Okay, so can you explain it again because your voice was not audible previously? Just tell us the whole idea,
Okay.
like what your idea is and how you are trying to work on it.
Okay. Uh, so yeah, as you can see in the screen. Hello.
Yeah, carry on.
Yeah, as you can see, the path of the rover is a narrow one, so it is having terrain on both sides. So I will try to do the thing that it can follow the left or the right wall. I mean the mountains. So and all the rock samples will be present at the side. Can track board. So
Nilutpal, we can't hear you. Sorry. Hello?
Hello, Paul.
Hello?
Hello, mute Paul.
Excuse me, judges. The participant is facing a little problem regarding his connection and everything, so his voice is a little unclear. He'd like to present a written file or a presentation regarding his project, and he'll definitely present it to you in the written form about how he's trying to implement it. So please take note of that. Yes, definitely. The participant will send a summary regarding how he's going to implement the idea. So, ladies and gentlemen, and the gentlemen in the judges panel, thank you so much for joining us today. Thank you so much for your valuable time. Um, As we are close to concluding the MLH Local Hack Day Share 2020, I'd like to thank each and every one of the attendees, participants, and esteemed speakers for making the event successful. As you all know, the Developer Student Clubs, Sharda University, hosted, organized, and put this event together. So I'd like to take this opportunity to thank the 7-membered organizing team, the efforts of which made this event possible. We have Afrata Saduk as the host of the event, that would be me. A special thank you to the content moderator, Mr. Ninatpol Kashyap, and I highly appreciate the work and efforts of the technical support team, which is made of brilliant students of Sharda University, Mr. Prashant Singh, Ms. Srishti Singh, Mr. Shivam Riyar, and Mr. Rupender Singh. We are delighted that you all could join us today, and we hope that you enjoyed learning and presenting as much as we did putting the event together. Also, we are grateful to the esteemed speakers for taking some time out for us. We highly appreciate it. We'd also like to thank the panel of judges of the project demonstration, Mr. Faizan Akhtar, Mr. Anupam Bhattari, and Mr. Ashutosh Srivastav. Thank you so much, ladies and gentlemen. Thank you for joining us. Let's stay connected and let's stay home and stay safe. Thank you.
Bye, guys.
Thank you, everyone. Bye.
Thank you so much.
Goodbye,
Thank you.
guys. It was great having you.
Yeah.
It was great having you too. Thank you.